I've been a full stack engineer now for over 12 years, and I've worked with a variety of different languages and technologies. My focus has primarily been on web and API development, and I've worked in a variety of industries from small startups to large Fortune 500 companies. Over the last 5 years, I've become increasingly passionate about Elixir and Erlang, and I've decided that I will only accept roles that primarily use this technology. In this series, I'd like to explain why I've made that decision, how Elixir compares against other competing technologies in the space, and where I wouldn't use Elixir. First off, I do know that comparing languages and saying one is better than another or this or that tends to be non-productive. I'll admit that. However, at the same time, I really do believe there's a cost to poor tech choices and using technologies that aren't the right fit for the job or perhaps are outdated. And working with certain languages can be enjoyable for developers while others not so much. Without naming names, I'll say that certain languages I've worked with extensively feel more like a toxic relationship where you continue to give and give without really getting what you're hoping in return. And Elixir really changed that for me, where it almost seems the other way around. Sometimes I feel I'm not worthy of this relationship, and Elixir keeps giving, which is, I guess, what you want out of a language. Of course, it's not perfect, and there are a few little things here and there that pop up that maybe are cause for frustration. But overall, in my experience, Elixir has been a very positive relationship. And considering the amount of time that I spend programming as a professional, that's pretty important. To drive this point home, I've identified 3 different criteria that I think are most relevant to web and API development here in 2021. And we'll compare Elixir to several other languages in these areas. Now, I certainly do not believe in a one-size-fits-all, and I definitely believe there are plenty of use cases that Elixir is not appropriate for. However, for anything web or API related, especially anything that may need to scale quickly, I believe Elixir really is head and shoulders above the competition. But before I make my case for that, I'd like to describe the 3 different things that I think are most relevant to web and API development. First and foremost, I think concurrency is the name of the game when you're talking anything web or API related. Asynchronous programming tends to be one of the most challenging aspects of modern development, and there are a variety of different approaches and techniques used across the different languages available to achieve concurrency. Being able to serve web and API requests at scale is largely dependent on how well a language or technology handles concurrency. And although in this day and age of cloud computing, it's easy enough to just add more machines and more processing power and memory, at the end of the day, that may just be a band-aid for something that could have been solved with a technology that was optimized and built around handling concurrency. And that's why I think the most important criteria for evaluating modern languages, especially for web and API development, is how that language handles concurrency. The second most important criteria that I've identified for this series would be around productivity. You could have the most elegant or performant or scalable technology available, but if it's not productive, if you can't build things quickly and effectively with it, then it probably is not going to be the right choice, regardless of how powerful that language may be. So there does need to be somewhat of a balance between productivity and scalability. A language that comes to mind when thinking of productivity is Haskell. I can't help but admire the genius behind Haskell, but despite my efforts to learn category theory and lambda calculus and these different fundamentals behind the language, it still seems too impractical to be a mainstream language, despite how powerful and elegant it is. I also believe there's a short-term and long-term aspect to productivity. Some languages might give you a lot up front, but as the project begins to scale and get larger and you have more developers, more features, that productivity can start to decline, whereas others may take a little bit longer to get going with, but ultimately scale better in the long term as the code base expands. And finally, the third aspect of programming languages that we'll look at is raw performance. I find it's very common for new languages to come up with various benchmarks and tests that demonstrate its raw performance. And while for some languages and use cases, this may be very important, for web and API specifically, I don't think it's as relevant. The reason for this is I tend to think in orders of magnitude when it comes to performance, especially if you're building like a web or mobile app. The majority of time, your user is going to be waiting for network tasks rather than CPU or memory access. And so the ability for a language to process a linked list faster than another, those benefits are going to be largely outweighed by the network implications of requests that are going over the wire. So although raw performance is something that you'll need in certain use cases, overall, I don't think it's nearly as important as the other two criteria. In addition, performance benchmarks really can only tell part of the story. There are so many different types of things that you can do in a programming language that highlighting 2 or 3 benchmarks that outperform competitors really don't tell the whole story. Plus, with the prevalence of microservices today, we are afforded the ability to pick and choose different languages for different purposes. So if we need something that is highly performant when it comes to CPU-bound operations, then we can pick the right tool for the job and isolate that to one microservice while using a different technology as suited for other purposes. So overall, as long as these languages are fairly ballpark in terms of performance, I don't think it's really going to matter when compared to how well these technologies handle concurrency, which really is the network aspect of performance, as well as how productive they are, which really is going to determine how fast you can ship new features, how fast you can diagnose system bugs, and how fast you can scale these systems. So in order from most to least important, we're going to look at concurrency, then productivity, and then finally performance. And although we won't be looking at obscure languages here and try to keep things realistic as far as language choices, we're also not going to be looking at popularity. And I understand sometimes that popularity can really be considered the most important criteria for business, especially because of hiring and skill sets of existing engineers and the community at large. I think that's what leads to suboptimal choices when it comes to deciding what to use for a business or a project. And oftentimes, siding with the majority is just going to lead to average results. So if you're looking for a competitive edge, or you want a way to move faster and more efficiently than the competition, probably need to be looking outside of what your competition is doing. If you're more concerned about preserving the status quo or more risk adverse, then I suppose more popular technologies may be appropriate. So it ultimately does come down to your business strategy. But at the end of the day, if we continue to use technologies based on their popularity rather than the benefit and merit of those technologies, then we'll be doing ourselves and really the industry a disservice by not evolving with the technology that becomes available. And sure, we will always have legacy systems to maintain, and there will be certain constraints that we need to work within. Ultimately, there are real costs to poor technology choices, and most of the time, these can be avoided. So before I end off this introduction, I'd like to give a brief preview of the languages we'll be evaluating and what use cases I think they are most appropriate for. We will be looking at Go, which I think is an excellent choice for the enterprise, maybe more conservative organizations that want to sort of maintain the status quo, but also move away from Java and recruit Java engineers with little friction. We will be looking at Rust, which I believe is a no-brainer replacement for C, C++, and is the ideal language to be used when the most raw performance and low-level language is desired. and we will be looking at Node.js, which I believe should be largely replaced by Elixir and limited simply to JavaScript UI development, particularly React, whereas Go and Rust serve some specific use cases better than Elixir, and I'd say aren't necessarily competitors to Elixir. Node, on the other hand, is probably the most relevant competitor to Elixir, and the biggest barrier to Elixir becoming the go-to for web and API development moving forward.